Okay, in this video we will solve 2.77, which is in tutorial 2. Okay, so in this question you have a non-symmetric binary communication channel shown in figure 2.3 below. Okay, assume that the input is 0 with probability p. So I am labeling the input with x and the output with y. So it's given that probability x equals to 0 is p, and the probability that x equals to 1 is 1 minus p. Okay, so A, you asked to find the probability that the output is 0. In other words, find the probability that y is equal to 0. Okay, so if you look at the diagram here, okay, so it's important for you to understand what does the values that is written on the branch, what does it mean. Okay, so these are actually condition probabilities, whereby, for example, if you look at this line here, it connects between input 0 and output 0, and then the value that is written up is 1 minus epsilon 1. Okay, and when x is 0, it can also receive a 1 instead of a 0. So the output is incorrectly received. Okay, and this is the probability of error, epsilon 1. Okay, so these two add up to 1, as you can see, right? So basically sometimes they only give you epsilon 1 here and epsilon 2 here. You should know that for this branch the value is 1 minus epsilon 1, and for this branch the value is 1 minus epsilon 2. Okay, so this probability that is given here is actually a condition probability, whereby you have the probability of output given that the input is 0 is 1 minus epsilon 1. Okay, and this, for this branch, the probability that the output is 0 given that the input is 1 is epsilon 2. So this is the probability of error. Okay, similarly, you have for this branch the probability that you receive 1 given that the you sending a 1 is 1 minus epsilon 2, and the probability that you receive a 1 given that you actually send a 0 is the probability of error epsilon 1. Okay, so using this value that you've obtained here, how do we find the probability that y is equal to 0? Okay, so you've learned before that we can use the theorem of total probability to find this. Okay, so this is given here. Okay, in this section here. For A, find the probability of y equals to 0 using the theorem of total probability. So we can use the condition probabilities as follows, okay, to find the probability of y equals to 0. Okay, and for B, you are asked to find the probability that the input was 0 given that the output is 1. Okay, so given that the output is 1 is the condition probability. Okay, so this is how you write it. The probability that x is 0 given that y is 1, or output is 1. And you are also asked to find the probability that the input is 1 given that the output is 1. So this is the input is 1, and then you have this line to indicate the condition on the output is 1, y equals to 1. Okay, so let's look at how we find this value as well as this value. Okay, so from our diagram, you know that you only have the probability of the output given the input. We don't have the probability of the input given the output. So you can actually use Bayes' theorem to find this. Okay, so using the definition of the condition probability, you have the joint divided by the probability of y equals to 1. Okay, and this you can also obtain from the condition of probability of the output given the input, right? Okay, so this is actually Bayes' theorem, right? So using this information that we have, we can now find the probability of the input given the output. Okay, so here we can get from the diagram here. Okay, but for probability y equals to 1, we need to find it. So just like how we did in A, where we found the probability of y equals to 0, we can use the theorem of total probability to find the probability that y, the output, is equal to 1. Okay, so we use this theorem of total probability and found it to be equal to this. Okay, so now we can find the probability of the input is 0 given that the output received is 1. Okay? And then we also use the same method that we found for this, okay, to find the probability that the input is 1 given that the output is 1. Okay? So we found it to be as follows. Okay? So the next section, the next part of our question is asking which input is more probable. Okay, I think it's which probability between the two. Okay, you have the probability of the input given the output is 1, which is which should be more probable. Okay, I think the question is a bit it's a bit not very clear. Okay, so I rephrase it to be something like this: for a good communication channel, which probability between the two, between this and this, should be higher or more probable? Okay, what do you think? Should this be higher than this, or this is higher than this? Okay, so let's look at what does this and this mean. Okay, so if you look at this expression, it means that what is the probability that you actually send a 0 given that you receive a 1. Okay, so this is actually the probability of an error occurring, right? And this, if you look at this statement, what is the probability that you send a 1, okay, given that you received a 1? So by right, this probability should be more than this. For a good communication system, it should be you should have a higher probability of a correct communication compared to a communication that is in error. Okay, so this is how I end the question. Between these two, I should have the probability of this to be higher than this, right? So I think that's how we should end this. There's no in the solution that I've given you before, I will correct it to reflect this as our final answer. Okay, all right, thank you very much.